So it says a set of numbers 1, 7, 11, and 36 contains are the values for M. What one can we use to make the statement true? 4 times M plus 8 equals 36. So which one of these numbers will make my statement true?
I'm thinking 7.
Okay, so how would we know? What would we need to do?
Sorry. You'd need to first multiply 1 times 4, which equals 4, 11 times 4, which equals 44, and 7 times 4, which equals 28, plus 8.
All right, correct.
30, 31, 32, 33, 34, 35, 36.
Yes.
That's up.
So 4 times 7 is 28. And if we add that together, we get 36 equals 36. So 7 is the correct answer. So 7 is the correct answer.
Can you keep it up?
Yep.
My cousin. Asked him to turn it down for you guys.
All right, those of you that are waiting, we are on page 445. 445. And it should say display data in dot plots. So 445.
Wait. Page number 445?
Yep.
Okay. This will be fun.
All right, are you ready, Gia?
Yep.
Yep. Okay. All right. So it should be displaying data in dot plots. So our objective today is we're going to construct and analyze a dot plot. So our vocab is a dot plot is a visual display in which each piece of data is represented by a dot above a number line. The number of times a data value occurs is called the frequency. All right, so it says statistical questions are answered by collecting and analyzing data. One way to understand a set of data is to make a visual display. So a dot plot is a type of a line plot that shows the frequency of each data value using a dot. All right, so our data is the pulse rate is the number of times a heart beats in a minute. The pulse rate for a group of 12-year-olds is taken before physical education class. The results are shown in the table. Which pulse rate is the most common among the group? All right. So it says complete the number line with the appropriate scale. So look at these numbers. What is my lowest pulse rate?
Answer this one?
Yeah.
Okay. If we look at the pulse rates, we see...
What's the lowest?
55.
Yes. All right. What is the highest?
The highest would be... Let's see... I'd say 85.
Yes, I would agree with 85. All right, so our scale is going to go from 55, so that's what goes here, right? Now, so we don't have to label every dot. So if we were to label every dot here, our numbers would be so close together that we wouldn't be able to read them, okay? So if this is 55, this would be 56, and the next one would be what?
57.
Yep. And then this one would be 58. Then they gave us 59. Then 60. So the missing square would be 61. All right, so hopefully you guys can see the pattern, right? So each square jumps how many numbers?
One number.
Not each square.
I mean, it jumps at least
57 to 59, 59 to 61.
It jumps 2.
Yes. So this would be 63.
65.
Yeah.
And then the thing rotates again.
Okay. So then 67, and then what's the next one?
69.
Yeah.
71. 73. 75. 77. 79. 81.
83, and then 85.
Yes. All right. So that means my scale goes from 55 to 85 as well, as you can see. All right. So now you are going to put a dot. So look at your data points and then put a dot where you think those go. Okay? So you guys plot it while I'm plotting it myself. All right, so someone said I did 56 wrong. Let me see. Let me go back. I could have. No, I think you're right. Where did I get that wrong?
There's also supposed to be a 58.
Yeah, maybe that's what I did. Is I put it at 56 instead of 58. 63 should be 2 here, 1 here. Skip 1. 1, 2, 3, 4. 1, 2, 3. Yep. Okay, that looks right. Sorry.
Yeah, it
looks right now?
Like how
Okay.
I did.
Awesome. All right, so let's use this information to answer the questions for B and C. It says for each data plot, we already did B. Yeah, we did B. All right, so C says, which pulse rate is the most common among the group of the 12-year-olds? Gia.
75.
Yep, and how do we know?
Because it has the most dots.
Yeah. Because 75 has the most data points. All right, good. All right, so think about the turn and talk. It says, are dot plots useful for a large volume of data? So let's say we had 500 data points. Would it be good to make a dot plot? No, that's way too much data. So we're going to write no with a large volume of data. It would take too long to plot. Yeah, plotting 500 data points would be a long time.
Pick this up.
Are we ready?
Not yet. Can you say that last? Oh. Never mind. I'm ready.
All right. All right, so look at the back. They've already plotted it for us, right? So it says a company's employees are rated for their customer service on a scale of 1 to 10, with 1 being very unhappy and 10 being very happy with the service. The customer service rating for one day are shown in the dot plot. Use the dot plot to describe the data. So what is the most common rating for the day?
7.
7. And how do we know?
It has the most dot
Yeah,
plot.
because it has the most data points. Yep. All right. So what is the least common rating for the day?
Can I answer this one?
Sure.
Number 1. Because
1.
it has the least data points.
Yep, because it only has 1 data point. All right. How many observations are shown? So what do we need to do?
We have to count all the
Count the
dots.
dots.
Yep, count the dots. So how many do we have?
You have 40.
I have 40. Thank you. All right. So if the rating of 6 or higher is considered acceptable by the company, what % of ratings are unacceptable? So we know there are 40 total ratings, and how many ratings are below 6? So that means we're going to count everything this way. So how many are below?
12.
Yep. Gia, did you have a question?
No.
Okay. All right. So my fraction would be 12 over 40. Now, what can we do to find that percent?
40 divided by 12.
Yep. So 40, that's one way I could do it. So 40 goes into 12.0. What else can I do to that fraction?
We can compare it against the actual percentage. I think we've learned about this before.
Yep. So we could scale up or down, right? And so we know we want to get to 100 because we know it's 100%. Does 40 go into 100 nicely?
No, but if you divided 12 and 40 by 4, you could get that down to something over 10.
Yep. So everybody hear Miss Capel? She
Would go
said,
nicely.
if you divide each one by 4, we would get a nice number that would go into 100. And what would that nice number be? Say it again. I couldn't hear you.
3 over 10.
3 over 10. Yep. Now that goes into 100 nicely, right? So 10 times what would give me 100?
10.
Yes. So that means 3 times 10. So what would I have?
30.
Yes, thank you, Alejandro. 30. So 30 over 100 is what percent? What do we say that?
30% of the
Yeah.
ratings.
30%. So 30% of the ratings are considered to be unacceptable. All right, so we're going to do the same thing for E. But now we want, so if a rating of if a rating of greater than 8 is considered excellent, what percent of the ratings for the day are considered excellent? So once again, we're still out of 40. Okay, so we're going to go 8. We can't use 8 because it's above 8. So how many 9s and 10s do I have?
9.
9, yep. So that would be 9. So 9 over 40. So what about this one? Does this one give me a nice fraction?
Yes.
Okay.
Actually, you might have to just divide it out.
Yeah. So someone said yes, though. So what kind of fraction do you think we get? Can I reduce that?
I don't think so.
Yeah, the only thing that would go into 9 is 3. And if I divide 40 by 3, I don't get a pretty number. I get 13.333333333. It repeats. So we can't reduce this. So what we're going to have to do is divide. So 40 divided into 9.0. So I'm going to bring that decimal point up. And we know 40 doesn't go into 9. 40 divided into 90 goes how many times?
2 times.
2, yep. Which is 80. So it leaves me with 10. Add a 0, bring it down. So 40 into 100 is?
Still 2.
Still 2. Which is minus 80. Which leaves me with 20. Add a 0, bring it down. So 40 into 200 is how many times? 5. All right. So we have a decimal. What do we do when we have a decimal? How do I convert it to a percent?
We move it 2 places.
Yep. So I get 22. So it's here, right? So 1, 2. So I would have 22.5%.
Percent means out of 100.
Mm-hmm.
And we can't use that for a fraction or a decimal.
Yep. All right. So what happens to our data if we add 5 customer ratings to the 10 column? So let's go back up here. So I'm going to add 5 here. So 1, 2, 3, 4, and 5. All right. So the question says, will it change our answers in parts A through F? All right. So let's look. So in A, it says, what is the most common rating? So does 7 stay the most common?
Nope.
No.
It's 10.
Yep. So A will change from 7 to 10. Okay, what about B? B says, what is the least common rating? Does that change?
Nope.
Nope. So that would be no change. What about C? How many observations are shown? So does that change when we add 5 to it?
5.
Yeah. So this one will change from 40 to 45.
And I think it's just from A through E, not F.
Right, well, because we're on F, right? All right, so what about D? Will D change? D says, if a rating of 6 or higher is considered acceptable by the company, what
It will change because the total ratings change from 40 to 45.
Yes. So what changes? The numerator doesn't change, right? But the
No.
denominator changes.
It's also the same for E.
Yep. And then E, but will my numerator change? Because remember, it was 9 and 10. Yeah, so it will now be 5. So 9, 10, 11, 12, 13, 14, right? So that one will change from 14 to 45. All right, and then this one, we can divide 3 into it, right?
Yeah, you can, 12 divided by 3 is 4. And then 45 divided by 3 is what, 15?
Yeah, but does that help me?
Not as a percent, no.
Yeah, doesn't help me as a percent. But what it does help me with is it gives me a little bit smaller of a number to divide, right? So if I divide 15 into 4.0, I would get 2, which is 30. 10, add a 0, bring it down. And then I would get, it's a repeating decimal, I believe.
It's
6, right?
6, yeah.
Which is 90. And then what's going to happen, is it repeats. So what happens is, guys, you're still going to get 2, 6, 6, 6, 6, 6, 6 all the way out. So we're going to round it. So I'm going to put my little squiggly line because it means it's approximately, because we rounded to 27%. Okay? And then this one, I don't think anything can go into that one.
That one's a division one.
Yep. So that one we can't make any smaller. So I'm going to move it over here. So we're going to do 45 into 14.0. And then 45, I know, goes in 3 times. Which is 135. And then we get 5 left over, bring the 0, bring it down. So 1 time, and then what's going to happen?
It's repeating.
Yep, it's going to repeat. So that means we would have a 1 here. So we would round this to 31%. Okay, so they definitely both change when we add more data points to it. All right, so what about the turn and talk? How is a dot plot different from a number line? So how is it different?
With a dot plot, there's a bunch of different dots, and you have to, when you count it, you're basically counting those dots on the number, so it's more than the actual number line.
Yeah. So a dot plot is a bunch of data points, right? And then a number line could either be 1, because if it's a solution to an equation, it's 1 dot, or if it's an inequality, depending on that inequality, right, it could be 1 open circle with an arrow, or it could be a closed circle with an arrow, depending on what my sign is. So this one's greater, but I could also go in the less than. So inequality is multiple solutions, but we don't have multiple dots, if that makes sense. All right, so I want you guys to work on number 3. Number 3, I'm going to give you 5 minutes to get those plotted. and answer those questions. All right, number 3 on your own. And if you get done with before the 5 minutes is up, move on to the check understanding. Okay, y'all have a good day.
Bye.
Bye.
Have a nice day.